You've built a LangChain application. It works on your machine, the demo went great, and then it hits production. Suddenly your agent is hallucinating tool calls, your retrieval chain is pulling irrelevant documents, and your costs are creeping up for reasons you can't explain. The hardest part isn't building these LLM applications anymore. It's understanding what's actually happening inside them. And that's exactly the problem LangSmith was designed to solve. Let's start with the core challenge. A modern LangChain application isn't a single function call. It's a sprawling tree of operations. A prompt template gets formatted. A retriever queries a vector store. The results get stuffed into context. The model generates a response. Maybe an agent decides to call a tool. That tool returns data, and the loop runs again. When something goes wrong, traditional logging gives you almost nothing useful. You see an input and an output, but everything interesting happens in the murky space between them. LangSmith makes that space visible. Tracing is where it all begins. When you connect your application to LangSmith, which is often as simple as setting a couple of environment variables like LangChain_tracing_v2 and your API key, every run gets captured as a hierarchical trace. You can click into a single user request and see the entire execution tree. Each chain, each LLM call, each retriever, each tool, nested exactly as they ran. For every node, you get the exact inputs and outputs, the token counts, the latency in milliseconds, and the cost. So when your retrieval-augmented generation app gives a wrong answer, you can immediately see whether the retriever pulled bad documents or whether the model ignored good ones. That distinction changes everything about how you fix the bug. Let me give you a concrete example. Imagine an agent that's supposed to look up a customer's order status. In the trace, you notice the agent called your lookup tool with the argument order number 12,000 as plain text instead of the integer the function expected. The tool threw an error, the agent improvised, and the user got nonsense. Without tracing, you'd be staring at a vague complaint. With it, you found the root cause in 30 seconds. Your prompt needs to specify the argument format, or your tool needs better schema validation. But observing one request at a time only gets you so far. This is where evaluation comes in. LangSmith lets you build datasets from real production traces. You can flag interesting or failing runs and add them to a curated test set. Then you define evaluators. These can be heuristic checks, like whether the output contains a required string or matches a regex. Or they can be LLM as judge evaluators, where another model scores your response for correctness, relevance, or helpfulness against a reference answer. You run your chain across the whole dataset and get aggregate scores, so you can answer the question that actually matters. Did my change make things better or worse? This unlocks proper regression testing for non-deterministic systems. Say you want to swap your prompt or upgrade from one model to another to cut costs. You run both versions against the same evaluation dataset and compare them side by side in LangSmith. You might discover the cheaper model scores 94% as well on accuracy while having your spend, or that it quietly breaks your edge cases. You're making decisions with data instead of vibes. And then there's ongoing observability. In production, LangSmith dashboards track latency percentiles, error rates, token usage, and cost trends over time. You can set up monitoring to catch when feedback scores drop or when a particular chain starts failing more often, and you can collect real user feedback signals directly tied to specific traces. So that's the workflow. Trace to understand, evaluate to improve, and monitor to stay ahead of problems. Together, they turn LLM development from guesswork into engineering. If you found this useful, subscribe for more deep dives, and I'll see you in the next one.